This is the fifth in a series of videos on Introduction to Exponential Functions, and in this one we're going to look at a couple of word problems. So for the first problem, let's look at the situation that we have locally, and that is the population of deer in Pacific Grove is 1,203, and it's growing at a growth rate of 12% per year. And the question is, how many deer will there be in 19 years? So anytime something's exponential growth function, that means that there's a constant rate of growth. That's the key, constant percentage rate of growth. So let's look at this key. The formula that you're going to want to use with exponential growth or decay is always the same. It's y is equal to a, parentheses, 1 plus r raised to the t, where a is the starting value. And y is the ending value. And x is the number of time periods, or t, sometimes it's called t or x, is the number of time periods. Typically when we're doing math we call it x, but when we're doing word problems we often call it t. And r is the growth rate per time period. And if it's negative, that means it's a negative growth rate or a decay rate. So in this case, let's go back to our problem. In this case, the initial value is 1,203, so A is equal to 1,203. And the growth rate is 12%, so R is 0.12. So the formula that you're going to use is Y is equal to 1,203, 1.12 raised to T. And that's the formula that you're going to use. And then in this case, we're going to use it after how many years? In this case, it's 19 years, so t is equal to 19. So you're going to have y is equal to 1,203, 1.12 raised to the 19. Now we still have to evaluate that, but let's stop and make sure we understand what that is first. Right? Here, from the problem, we know what the starting value is, a, we plug it in. We know what the growth rate is, it's 0.12, so we add that to 1 to get the growth factor, they call it, 1 plus r at 1.12. Then we know that we want to evaluate the total amount after 19 years, so t is equal to 19, you plug it in. And now you're going to want to evaluate that in your calculator, so let's do that next. Well, here you have to, again, remember your PEMDAS rules, right? Please excuse my dear Aunt Sally. So you're going to do the exponent first. So in your calculator, you're going to do 1.12 raised to the 19th. So that's 1.12 raised to the 19th. That's about 8.613. We round it. I'm not going to round it. I'm just going to leave it in my calculator. Put an approximate there. And I'm going to multiply that times 1203. And you get 10,361.15. Really, deer can't be approximated. I mean, it can't be decimalized, so your answer is going to be 10,361 deer, which is a lot of deer. Let's look at another example. And the next example we're going to look at is, let's look at an investment problem, and that is you invest $1,500 with your brother-in-law who promises a rate of 9% per year. And the question is, how much money will you have in 7 years? And then, how much money will you have in 25 years? So we use exactly the same formula we did before, right? Y is equal to a, 1 plus r to the t, where a is the starting value, y is the ending value, t or x are the time periods, and r is the growth rate. We're going to assume for a moment that you can believe your brother-in-law. It's not always a good idea. So you have 1 plus r to the t. In this case, a is 1,500. That's the amount of money you start with. The growth rate is 9% per year, so that's 0.09. We're going to convert that to 1 plus r is equal to 1.09. So we get y is equal to 1,500, 1.09 raised to the t, and that's going to provide us with our formula that we're going to use. Now, if we know how many years we put the money in, then we know how much money we end up with. So if t is equal to 7, then you plug in y is equal to 1500, 1.09 to the 7. If it's 25 years, then you have y is equal to 1500, 1.09 to the 25. You just plug those into your calculator. Remember your PEMDAS rules again. So that's 1.09 raised to the 7, 1.828, and then times 1500 is $2,742.06, rounded to the nearest cent. If we have 25 years, then we go 1.09 raised to the 25. And that's about 8.6. Let me try that again. That's 1.09 raised to the 25th is about 8.623. And you're going to multiply that by 1500, and you get 1293462. And that's how you do word problems.